So if you remember categorical variables, variables can be classified as either categorical or quantitative. And in this case, categorical variables provide groupings that either have a logical order or not. Um, and if there is a logical order, there's an inconsistent difference between the groups. So we can use, when using one categorical variable, um, we can summarize this using a proportion. And a proportion is the number in one category divided by the total number. So the symbol for a sample proportion is p hat. So it's lowercase p with a little caret on the top. And the symbol for a population proportion is just a p. And it can also be summarized by x over n. X is the number in the sample, the category of interest, and then n is the sample size, the total number in your group. And one last thing, a proportion must be between 0 and 1, so you cannot have a negative proportion or a proportion that is greater than 1. So the first review, a bag consists of 2 different colored marbles. There are 36 green marbles and 71 blue marbles. In total, there are 107 marbles in the bag. What proportion of marbles are blue? So we're looking to find the proportion of blue marbles here, and the answer is 0.66. So when we go back to that proportion formula, we're looking for the number in the category over the total number. So in this case, the number in the category we're looking for is the blue marbles, and then of course over the total marbles. And then that comes out to be 71, since there are 71 blue marbles over a total of 107, and that proportion is 0.66. Next, we're going to talk about risk. So risk is the probability that an event will occur. You can see it written, you can see it in decimal form, fraction form, or percentage form. And the formula for risk is number with the outcome over total number of outcomes. So to put it in an example for you, flu risk, which we'll be looking in the next example as well. So 45 out of 100 children get the flu each year. So the risk is 45 over 100, or 0.45 or 45%. So going back to the formula of the number with the outcome, so 45 children get the flu, so that's the outcome of getting the flu, is our numerator. And then the total number of outcomes is 100. So 45 over 100 is 0.45, and it can be summarized by 45% of children get the flu each year. So next is odds. Odds, it's important not to confuse risk and odds because they seem similar, but odds compares the likelihood of an event happening with the likelihood of an event that will not happen. So it's a different interpretation from risk, but it really just compares risk. So odds is number with an outcome over number without an outcome, or it can be or the formula could be risk over 1 minus risk. So here, if we're using the formula or the example from the last, from when we went over risk before of flu risk, since we already calculated flu risk, we can use the second formula that's on the right there of risk over 1 minus risk to calculate the odds. So the odds like of a child getting the flu. So we could take 0.45, which is the flu risk, over 1 minus 0.45 and get 0.818. And then we can summarize that by saying the odds of a child getting the flu is 0.818 to 1. So here's some visual representations that come up during this lesson here. So you can use these to visualize data. A pie chart on the left and a frequency table on the right. They each are representing the same data of Penn State Math Club, for example, the ages of each member of the group. And the pie chart is more of an illustration. You can clearly see the biggest slice of the pie chart obviously has the most the highest number in the Penn State Math Club. So here, since the gray is the bigger chunk, so it shows that the 21-year-olds are they're the most of the people in the Penn State Math Club are 21, and that it is also represented in the frequency table on the right that just shows a breakdown of each number. So it's less of a illustration as a pie chart, but it's still very clear. And then a bar chart shows the same data of the Penn State Math Club, and you can just see the longest bar, which is 21 again. 13 students are 21, and that's the highest number for an age in that group. So it just shows that most students are 21, and then the shortest bar is 19, so only one student is 19 in the club. So those charts that I just showed, the pie chart, the frequency table, and the bar graph, are used to describe one categorical variable, and you can use a two-way table here to describe two categorical variables. So you see the two categorical variables here are gender and class standing. So we have males and females for each class standing of freshman, sophomore, junior, and senior. So it just shows a breakdown of the numbers for each class standing and each gender. So probability. Probability is the chance that event A will occur. So you will calculate this by saying the number in group A over the total number. It seems very similar to a proportion, and the range of probabilities is something important to keep in mind. So probabilities range from 0 to 1. So if you get a probability of 0, that means that there is no chance that an event can happen. So an example of a probability of 0, so the probability of rolling an 8 on a 6-sided die. There are only 6 sides to the die, you cannot roll an 8, so that probability would be 0. So disjoint and independent events. So disjoint events are events that never occur at the same time. So they can occur at different times, but they cannot occur at the same time. Next, a Venn diagram is a visual representation, as you can see on the right, the little box with the circles in it, and in which the sample space is depicted as a box, and events are represented as circles within the sample space. So each circle there, A and B, represents an event happening in the space. And then independent events are unrelated. So they're not related to each other. The outcome of one event does not affect the outcome of another event. So if something happens in one group, that doesn't necessarily mean that that effect, whether it be positive or negative, will have a positive or negative effect on the other event. So an example of disjoint independent events, to kind of put it in a good perspective, is if you consider undergraduate class status again. So a student can be identified here as a freshman, sophomore, junior, or senior. So being a sophomore and being a junior are disjoint because an individual cannot be classified as both at the same time. So you can be a sophomore and then be a junior, but you cannot be considered a sophomore and a junior at the same time. So assume that there is no relationship between gender and class status here. So just in this example, this means that within each class of freshman, sophomore, junior, senior, the proportion of each student who are men is consistent, and the proportion of each student who is a female is consistent. So it also means that within each gender, the proportion of students who are freshmen, sophomore, juniors, and seniors is consistent. So that means that there's 25% in each class. So there's equally 1/4 freshman, 1/4 sophomore, 1/4 junior, 1/4 senior. So the events of being a man and being a senior here are independent. So if you see, if you just walk up to a random man knowing that he is a man here does not influence the likelihood of him being a senior. So in this case, gender and class status are independent events because if you take someone's gender, that doesn't necessarily influence him or her of being a freshman, sophomore, junior, senior. So combination events, these are good to know. So intersection is the probability of A and B. So both A and B will happen. This differs from union, which is the probability of A or B, but union includes that the possibility of A and B could occur. So it differs from intersection in that in union, A or B could occur, so it would be okay if just A happened, but in intersection, the A and B must occur. And then complement is the probability of not A. So the probability of not A here, and then conditional is the probability of A given B. So something happening as a result of something else happening. So we just did one categorical variable and two categorical variables, and now we're going to move on to one quantitative variable. Okay, so we discussed some visual representations earlier, and now we can discuss visual representations for one quantitative variable. So here, dot plots and histograms. So dot plots and histograms are graphical displays used with one quantitative variable. And in this case, on the right, I've shown a dot plot, and the number of dots in a dot plot or the height of bars in a histogram represent the number of cases within each range, within each value or range of values. So in this case, the dot plot on the right, in each dot represents one person in this case, since we're looking at height, and this is most likely people here that are being measured. So in this case, each dot represents one person. So outliers. So outliers are one or more observations within a set of data that may fall outside the general scope of the other observations. So you can identify them by looking at a dot plot, which is the example we have here, a histogram, or a box plot. So here you can see the outlier is the dot that is past 72 hours per week watching TV. So this is just really saying that it's astray from most of the other data. So this is kind of skews the data a little here with this outlier, and it, through the definition, it really just falls outside the general scope of the other observations. So it's kind of just like on its own. Usually they're really easy to identify since they stand out. But in this case, it's the one, it looks like it's around maybe 74, 75 hours per week of watching TV, which isn't in line with the other data that was collected here. So shape. So these two types of shapes are similar. So here shown on the left is symmetrical distribution, which is a distribution that is similar on both sides of the center. You can see that the bars are symmetrical to each other as they go from the center to the left and to the right. And then next to it is a normal distribution, which is a specific type of a symmetrical distribution. So you see that in the normal distribution, it is bell-shaped, and it has a mean of 0 and a standard deviation of 1. So if a type skewness can affect the shape of your distribution. So a distribution is considered skewed if values are more spread out on one side of the center than the other. So here on the left we have right skewed distribution, and on the left, on the right is a left skewed distribution. So in a right skewed distribution, the data tends to pile up on the left side of the distribution, and then it kind of trickles off near the right side of the distribution. So that's why it's called a right skewed, since it's skewed towards the right. And then it's just the opposite on the left side. So the data piles up on the right on the right side of the distribution, and then it kind of is more skewed on the left side. So that's why it's called left skewed and right skewed. So mean, median, and mode are three commonly used measures of central tendency, which you've probably heard about before. So mean is the numerical average. So it's just really another word for average. It's calculated as the sum of all the data values divided by the number of the values. So you see below the formula is sum of x over n, which is the sample size or the number of values. And we call a sample mean x bar. The symbol for x bar is just x with a little bar over the top, a little straight line over the top. And then the population mean is the symbol mu. It looks like a little U with a little tail on it. And you want to make sure you just know the difference between the population mean symbol and the sample mean symbol. You don't want to get those confused. And next is median. So median is the middle of the distribution. And you can find median by ordering the values from smallest to largest, and then finding the value in the middle of the distribution. So for distributions with an even number of values, you just take the mean of the two middle values. So you would narrow it down from left to right to get the two middle values, and then you just take the average of those two in the middle, and you would just add them together and divide by 2. So mode is the most frequently occurring value in the distribution. So I like to think of mode as most. So those two words are kind of similar. So it's the most frequently occurring value in the distribution, and it may be used with quantitative or categorical variables. So the mode is just the value that occurs the most in the distribution, whichever one is most frequent. So skewness can affect the mean, median, and mode. So in a symmetrical distribution, the mean, median, and mode are equal. When there is a left skewed distribution, the mean is less than the median, and the median is less than the mode. And then it's quite the opposite in the right skewed distribution. The mode is less than the median, which is less than the mean. So it's just some patterns to keep in mind as we go on. So standard deviation is a measure of spread. It measures variability in a distribution. So the formula for sample standard deviation is below. And standard deviation is just roughly the average difference between the individual data values and the mean. So the symbol for a sample standard deviation is a lowercase s, and then the standard deviation population symbol is lowercase sigma, which just looks like a little O with a little tail next to the side. So the empirical rule. So the empirical rule is a statement about normal distributions. You may also hear referred to as a 95% rule. So it's summed up in the illustration on the right and in the paragraph on the left. But the 95% rule states that approximately 95% of the observations fall within 2 standard deviations of the mean on a normal distribution. So the empirical rule just summarizes that on a normal distribution, about 68% of data will be within 1 standard deviation of the mean, about 95% of data will be within 2 standard deviations of the mean, and about 99.7% of data will be within 3 standard deviations of the mean. So in the image on the right of the distribution, you can see how that's kind of broken down. So you see the first block of 68% of the data. You see how that is in 1 standard deviation of the mean. Next is 95% of the data stretched out a little longer. That's 2 standard deviations of the mean, which is used most common in this course. And then 99.7% of data stretched out a little longer is in 3 standard deviations of the mean. So z-scores. So z-scores are used to describe an observation in relation to the distribution of all observations. So the formula we use to calculate z-score is x, which is our original data value, minus x bar, which is the mean of the original distribution, divided by the standard deviation of the original distribution. So we'll go over a practice problem in a little bit, going over z-scores. All right, so here is the question going over z-scores. So the average weight of a female border collie is 40 pounds with a standard deviation of 5 pounds. What is the z-score for a female border collie that weighs 34 pounds? All right, so the answer here is D. So when we go in to plug the values in our formula, our x will be 34, our x bar is 40, and our standard deviation here is 5. So once we plug in all those numbers, we get negative 1.2 as our z-score. So next. Okay, so percentiles. So percentiles are the proportion of a distribution less than a given value. So you probably have heard of percentiles they're used a lot in everyday life. To give an example of how a percentile is broken down is for test scores. So if a student scores in the 90th percentile on a test, then this means that he or she scored better than 90% of students who took the test. So that's pretty good. But that's just a general breakdown of what percentiles are saying here. So they're going to come up in a 5-number summary. So a 5-number summary is composed of 5 different numbers. So the first number is the minimum, which is the lowest value in a set of data. Q1, which is the first quartile or the 25th percentile. Next, the third number is the median, which is the middle value. The fourth number is Q3, which is the third quartile. It is the 75th percentile. And the last number, the fifth number, is the maximum, which is the highest value. So there are a couple things we can calculate through 5-number summary. So 2 of those things are range and IQR. So first with range is the difference between the maximum and the minimum. So to calculate range, we just take the maximum and subtract the minimum. So we just take the 5th number from the 5-number summary and subtract the 1st number from the 5-number summary. And then IQR is interquartile range. So it's similar to range in that we subtract the third quartile, or we subtract the first quartile from the third quartile. So Q3 minus Q1. So we can, if we're given a 5-number summary, we are able to calculate range and IQR. So we're going to do that right now. So a teacher wants to examine students' test scores. The 5-number summary for their scores is 74, 80, 89, 90, and 98. According to the 5-number summary, what is the range and what is the IQR? All right, so we're going to go over this one now. So range, remember, is our maximum minus our minimum. And here our maximum is our 5th number, which is 98. And we're going to subtract our first number, which is 74, and we get 24 as our range. So next we're going to calculate the IQR. So the IQR is Q3 minus Q1. So we look at our 5-number summary. Q3 is 90, and Q1 is 80. And when we subtract those, we get an IQR of 10.